Okay, part two, example two, last example of the course. And this is a pretty good one, so it's a nice place to finish. There's a few different concepts involved here. A cylindrical rod, diameter 1.7 centimeters, sits on a support as shown. So this is some sort of machine part or something like that. Who knows? Determine the height of the entire mechanism. So this is what we want, right? This is the unknown. And the way I see it, and there's probably tons of ways to do this one. There's lots of things we know and can do. Um, but the way I see it, it's this little piece here plus somewhere in here is the center of the circle, this circle, this piece there. So I'm going to call that piece 1 maybe. That's 2. And then there's the third part. The third part's not bad. So that's the radius, right? So that's just 0.6, and that's all good. I'm going to erase that now, just so you see our plan. Maybe I'll call it X, Y, and R or something like that. So we know what we're doing. So the height, call that H, equals X plus Y plus R. And I might even pull a trick here, and oh, no, I can't do that. I am going to pull a trick. I want to blow this up a little bit. So I'm going to take a picture of this and blow it up. Just so I can talk about it better. And hopefully you can do a decent job on yours. I'm going to call this X. This piece here, Y. And then R is that piece, which is the radius. So the radius is 0.6 centimeters. So that piece we know. The rest is actually fairly difficult. Let's get at it. Notice that for this piece X, what I can do if I'd like is draw a horizontal line straight across here. Then we kind of have to make an assumption that these lines are straight up and down, but then that's a 90-degree angle there, right? And if this angle is 130, then these pieces, and I'm going to maybe redraw that. Let me just sort of do a sketch of that. And that's where the circle is sort of sitting. The rod is sitting like this. Like that. There's the points of tangency. If this is 130, I split that in half. This is 65 and this is 65, isn't it? It splits straight in half. Then this piece, this in here, which is what we really want in that triangle, you see that's that right there. That's 65 and that's 65. You see where we're headed? Then this is just 90 subtract 65. This is 25 in there. How does that help us? Well, the idea is this whole thing is 1.4, and then I can find X by finding this little piece. Let me call it, let's see, maybe Z. Z here. X is just 1.4 minus Z. And I'm going to find Z using trigonometry, because this side, this opposite side, is Z, and the adjacent side is 1 centimeter. This is 1 centimeter right here. So in finding Z, I can find this first piece, X. So over here, I'm going to write X equals 1.4 minus Z, and I'm going to find Z over here. And it's opposite and adjacent. So that's the tangent of 25 degrees. Note to self, study for the exam. And that is, Z is about 0.47 centimeters. So then that means X is around 0.93. Not much going on about circle properties yet, is there? But we'll see that now to find this Y, We do. We need a circle property. And the circle property that we're going to use has to do with tangent, right? The tangent, this is a tangent, right? It's resting on the tangent to the circle. So what does that mean? That's 90 degrees. Say, well, how is that any good? I still don't know why. Well, in this triangle, this blue line that I just drew is a radius, 0.6. And so then, if that's 65 and that's 0.6, I can use trig to find y. So here, and now this diagram's no good for us. I'm just going to continue my rough work right here. So that 65, kind of this triangle here is blown up here, and this is y right there. That's 90 degrees, and this isn't drawn very well, but hopefully you see where we're headed. If not, ask in class, of course. Opposite and hypotenuse is the sine of 65 degrees is 0.6 over the hypotenuse. Cross multiply. Note to self, study for the exam. This is all stuff from the trig unit, and these concepts also came up in the vectors unit. It must be pretty important stuff, this trig. And then I get y is only a little bit more than the radius, isn't it? So if this is 0.7, that would be about right. And if I clunk that into a calculator, 0.6 divided by sine of 65, 0.67-ish about. And so now I've got my pieces. X was 0.93, y was 0.67, and then this last piece from here to the top is just the radius of the circle, 0.6, and I've got it. That plus that is about 2.19 centimeters. The height of the mechanism is 2.19 centimeters. And that, my friends, is it for MCT4C. Thanks for stopping by. Don't do anything I wouldn't do, and stay classy and make wise choices.